Hello everyone, welcome to Geeky Nerd. Today we will begin a new aptitude topic called boats and streams. Before moving into the video, I hope everyone would have become thorough with the previous aptitude topics of averages, ages, and time, speed, and distance. The topic of boats and streams has been divided into several parts for the convenience of the listeners. If you have not seen the videos related to the previous aptitude topics, click on the card or the links in the bio. In this video, we will be discussing about the introduction and basics of boats and streams. Like, share and subscribe the channel for more interesting concepts and shortcut methods for solving them. Without wasting any time, let's head into the video. Let us understand some of the prerequisites to solve the problems and understand the concepts related to boats and streams. Some of the important terminologies which we come across the topic of boats and streams are still water, stream, upstream, and downstream. So, what is meant by still water? If the speed of the water in river is zero, it will be considered as still water. That is, if the water is not flowing in the river, of course, the water will not have any velocity, hence speed will be considered as zero. If the speed of the water in the river is zero, then it is referred to as still water. What is meant by stream? If the water in the river is flowing in any direction, the water will be referred to as stream. So, if the water in the river keeps on moving, then it will be referred to as stream. So, this stream, depending upon the direction, is get classified into two types, namely upstream and downstream. That is, if a boat or a swimmer moves along the direction of the stream or moves along the flow of the stream, then he is referred to as moving in downstream. In case if the boat or the swimmer moves in the opposite direction or against the flow of the stream, then he is referred to as moving upstream. So these four terminologies are very important to understand the basic formulae of boats and streams. So, for understanding the formulae, let us assume that speed of the boat be x kilometer per hour and speed of the stream or current be y kilometer per hour. In boats and streams, the word stream can also be referred to as current. So, we assume that speed of the boat in still water as x kilometer per hour and speed of the stream or current as y kilometer per hour. So, as we said, when a boat or a swimmer moves along the flow of the direction, we eventually know that the speed will increase. Therefore, speed of the boat in downstream SD will become x plus y kilometer per hour. We have heard that a man has been hit by the flood. So, since the man goes along the direction of the flood, he will be washed away. So, similar to that, whenever a man or a boat moves along the direction of the stream, his speed eventually increases. That is, SD is equal to x plus y kilometer per hour. In case if he is moving opposite to the direction of the stream, the speed decreases. That is, speed of the boat or man in upstream direction will become x minus y kilometer per hour. So now we have found out the speed of the boat in downstream and speed of the boat in upstream as x plus y kilometer per hour and x minus y kilometer per hour respectively. In case if we want to find the value of x and y, we can use the third and the fourth formulae. The third and the fourth formulae simply comes by adding and subtracting the first two. If we add the first two formulae, we can derive the speed of the boat in still water, and if we subtract the second formula from the first one, we will get speed of the stream. That is, consider we are adding equation or formula 1 and 2, we will get 2x. So speed of the boat in still water we know it as x, therefore half of SD plus SU will give us speed of the boat in still water. Similarly, we know that the speed of the stream is y, therefore half of SD minus SU will give us speed of the stream. Thus, we understood the basic terminologies and the formulae related to them. Let us solve some examples to get the familiarity. Boat travels equal distance upstream and downstream. The upstream speed of the boat is 10 km per hour and the downstream speed of the boat is 20 km per hour. What is the speed of the current? So from the question it has been given that distance downstream is equal to distance upstream. And it is also given that upstream speed of the boat, that is speed upstream, is equal to 10 km per hour and speed downstream is equal to 20 km per hour. We are asked to find speed of the current. We know that the word stream or current emphasizes the same in both streams. That is, speed upstream can be written from the formula as x minus y, which is equal to 10. Similarly, speed downstream can be written as x plus y, which is equal to 20 from the question. We already discussed that if we want to find the speed of the boat in still water, we have to add the two speeds, that is addition of upstream speed and downstream speed. If we want to find the speed of the current, then we have to subtract 1 from 2. Therefore, 1 minus 2 will give me x minus y equal to 10 minus of x plus y is equal to 20. Upon solving we get 2y is equal to 10, which emphasizes y is equal to 5 km. Therefore, speed of the stream or speed of the current is equal to 5 km per hour. So, if we want to find the speed of the boat in still water, then we can substitute in any one of the formula and we will get the answer as x is equal to 15 km per hour. So, if they had given downstream speed and upstream speed, and if they are asking us to find out speed of the boat in still water or speed of the stream, then we can add both the speeds and subtract both the speeds and arrive at the answer. Let us solve one more example. What time will a boat take to cover a distance of 64 km along and against the stream if the speed of the boat in still water is 12 km per hour and speed of the stream is 4 km per hour? So from the question it is given that speed of the boat in still water is equal to 12 km per hour. That is x is equal to 12 km per hour and speed of stream is equal to 4 km per hour. That is y. So they are asking time taken by a boat to cover a distance of 64 kilometers. It is also given that distance is equal to 64 kilometers along and against the stream. So first let us consider downstream. Downstream means along the stream. Therefore, time taken is equal to distance traveled divided by downstream speed. So we know the distance traveled as 64 km. Downstream speed can be given as x plus y. Therefore 64 divided by 12 plus 4, which will give 4 hours. Therefore the boat takes 4 hours to cover a distance of 64 kilometers along the stream. Now let us consider the second half, upstream against. So again we know that time is equal to distance divided by upstream speed this time. So distance is equal to 64 kilometer. Upstream speed can be written as x minus y. Upon substituting, we get 64 by 8, which is equal to 8 hours. So from these two questions, we have to infer two basic points. That is, always downstream speed will be greater than upstream speed, and always time taken to row upstream will be greater than time taken to row downstream. Through this video, we had learned the definition of basic terminologies involved in boats and streams. After that, we learned how to calculate the speed of the still water as well as the speed of the stream. On the basis of these two speeds, we learned to calculate upstream speed and downstream speed. We had solved few problems both on the traditional method as well as on the shortcut methods. I insist all the listeners to practice solving more and more problems such that they can increase their confidence. Like, share, and subscribe the channel and convey it to your friends so that they can be benefited. Until we meet in the next video, thank you.